So when we think about dyslexia, you think about what's the brain's role in all of this? And you ask, what do we know about the workings of the brain in dyslexia? Is there a difference compared to non-dyslexics? Reading difficulties could be explained away in any number of ways. Now, however, men and women with dyslexia can point to an image of the brain's internal workings made possible by new brain imaging technology and say, here, look at this. This is the root cause of my problem. We know now exactly where and how dyslexia manifests itself in the brain. So you may wonder, how does functional brain imaging work? It is now possible to image the brain at work, during reading, in typical readers and those with dyslexia, using a remarkably patient-friendly technology, functional magnetic resonance imaging, fMRI. Functional MRI is based on the magnetic properties of a basic component of blood, oxygenated hemoglobin. In red blood cells, oxygen is bound to hemoglobin and transported throughout the body for delivery to working cells. The magnetic properties of the hemoglobin molecule change depending on the amount of oxygen bound to it. Blood with higher oxygen concentrations produces a stronger magnetic signal than blood with less oxygen. So, as a person carries out a specific cognitive task like reading, responsible neurons in sites distributed throughout the brain become activated. Blood flow to these brain regions increases, bringing with it rich, highly oxygenated blood. And the fMRI apparatus picks up its stronger magnetic signal. So here's a real treat. Meet the brain. The brain is an extraordinary organ, and for all its complexity and functioning, its organizing structure is relatively straightforward. As prelude to discussing functional brain imaging dyslexia, I want to point out some of the basic landmarks that I will refer to as we move forward. So here you could see the neural systems for reading. As shown in the figure, the brain is made up of two mirror image sides, or we refer to them as hemispheres, the right and the left. The front of the brain, near the forehead, is referred to as anterior. And the back of the brain, behind the ears and further back, is called posterior. So we have anterior and posterior. Each hemisphere of the brain is divided into 4 lobes or sections: frontal, parietal, temporal, and occipital. The frontal lobes are anterior, the occipital lobes, posterior in the back of the brain, and the parietal and temporal lobes somewhere in between. The parietal lobe, shown here in red, sits above the temporal lobe. There are mirror image lobes on each side of the brain. For example, the left temporal lobe and the right temporal lobe. Traditionally, the left side of the brain has been associated with language. Progress in our understanding of the neurobiology of dyslexia over the past 2 decades has been breathtaking. First, the neural systems for reading in typical readers, both children and adults, have been mapped out. Next, and most important, careful examination of brain activation patterns reveals a glitch in this circuitry in dyslexic readers. Studies from around the world leave no doubt. Dyslexic readers use somewhat different brain pathways than good readers do. Good readers activate highly interconnected neural systems for reading, encompassing regions in the front and back of the left side of the brain. Not surprisingly, the reading circuitry includes brain regions dedicated to processing the visual features, that is, lines and curves making up letters, to transforming the letters of the alphabet into the sounds of language, and getting to the meaning of words. The posterior reading system is made up of two distinct pathways for reading words, one sitting somewhat higher in the brain than the other. The upper pathway, shown in the figure in red, is located primarily in the middle of the brain, technically the parieto-temporal region, or PT, just above and slightly behind the ear. The lower, or occipital temporal path, runs closer to the bottom of the brain. It's shown in yellow. It is the site where two lobes of the brain, the occipital and the temporal, converge. One can envision this hectic region as a hub, a place in the brain where incoming information from different neural systems comes together, and all the relevant information about a word, how it looks, how it sounds, and what it means, is tightly bound together. The OT, that's the occipital temporal circuit, is barely beneath and somewhat in the back of the ear, near where children often get swollen glands associated with scalp or ear infections.
I think people get a lot of things wrong about dyslexia. First, I think a lot of people think that dyslexia is somehow an indication of people's abilities, their intelligence. It's somehow a limitation on their performance. Dyslexia is none of those things. Dyslexia is a different way of reading. It's a different way of inputting information. It doesn't have anything to do with people's ability to process data. It doesn't have anything to do with people's ability to think. And it has very little to do with people's ability to perform. So I think that probably the most important thing that people get wrong about dyslexia is they think it is somehow an indication of some kind of limitation on an individual's potential.